Okay, in this lesson we'll look at solving trig equations using identities. What you'll see is a combination of using identities to manipulate the equation and then usually some factoring to actually find the solutions. In all the examples from today's worksheet, we're asked to find the solutions on the interval 0 to 360, including the 0 but not including the 360. So you'll notice on the key there's a couple of errors where they ask you to, or they give you 360 as a solution. I'm just crossing those out now. And we know from our work in class that the solutions for problem number 4 here are incorrect. All right, we all did problem number 1. Sine of 2x equals cosine of x. First thing to notice here is that we have a double angle, 2x. We'll use the double angle identity to replace that. And sine of 2x is equal to 2 times sine of x, cosine of x. Well, that is equal to cosine of x. Next, you're going to be tempted, and we discussed this in class, you'll be tempted to divide by cosine on both sides. And that seems like a really good way to go, but you will not find all of the solutions by doing that. You cannot solve these equations by canceling out one of the trig ratios. What you need to do is get everything on one side and then factor. So we won't be doing that. What we will do is subtract cosine from both sides. So minus cosine x on both sides. Note that cosine x is not a like term with the cosine here. This cosine is part of this term with 2 times sine x, so we simply rewrite this as 2 times sine of x, cosine of x, minus cosine of x equals 0, and you will hopefully notice that we have a greatest common factor of cosine x, which we will factor out. This leaves us with 2 times sine x minus 1 inside the parentheses, so we have cosine of x equals 0, and 2 times sine of x equals 1, dividing by 2, sine of x equals 1/2. Cosine of x is 0 at 90 degrees and 270 degrees. Get that from our unit circle. And sine of x is equal to 1/2 at 30 degrees and 150 degrees. So there's our solutions for number 1. The next problem we all did in class was problem number 4. We have sine squared x equals cosine squared x minus 1. And we're going to use a Pythagorean identity here. It's not real important which one we use. Remember, we have sine squared x plus cosine squared x equals 1. And we can manipulate that to create an identity that we could use on either side. The easiest one to create is if I subtract cosine squared x from both sides, leaving me with sine squared of x equals 1 minus cosine squared of x. And I'm going to go ahead and substitute that right here. So we have 1 minus cosine squared x equals cosine squared x minus 1. Now we're going to bring everything over to one side here. So I'm going to, let's see, I would like to end up with a positive leading coefficient. So I'm going to add cosine squared x to both sides. And I'm also going to subtract 1 from both sides. This leaves me with 0 on the left and 2 cosine squared x minus 2 on the right. At this point, we're trying to isolate the trig ratio, so I will add 2 to both sides. 2 equals 2 times cosine squared x. We'll divide both sides by 2. These cancel. This reduces to 1. So we end up with cosine squared x equals 1. And we will take the square root of both sides, positive and negative, leaving us with cosine of x equals plus or minus 1. Cosine is positive 1 at 0 degrees and negative 1 at 180 degrees. The next problem that we did in both classes was number 6. 3 times cosine of 2x minus 5 cosine of x minus 1 equals 0. Well, again, the first thing I want you to notice is that we have a double angle here. We rarely, really never want to continue to work with a double angle. We'd like to replace that. And referencing our formula sheet, we see we have 3 choices for cosine. I think the best one is going to be the second one, where if we substitute, we'll have 3 times the quantity, 2 times cosine squared x minus 1. minus 5 cosine x minus 1 equals 0. And then simplifying by distributing the 3, we have 6 times cosine squared x minus 3 minus 5 times cosine x minus 1 equals 0. And now we'll combine like terms, negative 3 and the negative 1, giving us 6 times cosine squared x minus 5 cosine x minus 4 equals 0. And at this point, I'm going to substitute in a variable. I'll say let cosine of x equal the variable u, just to make it look a little simpler, easier to deal with, which gives us 6u squared minus 5u minus 4 equals 0. We'll use the big X for factoring. A times c gives us negative 24. B is negative 5. Factors of negative 24 that add to give negative 5 are negative 8 and positive 3. Bringing the 6u down and reducing, 2 goes into 6 3 times, 2 goes into 8 4 times, leaving us 3u minus 4. 3 goes into 6 2 times, 3 goes into 3 1 time, leaving us 2u plus 1. All that equals 0. Setting each factor equal to 0, I get u equals 4 over 3 on that side, and on this side I get u equals negative 1 over 2. Substituting our trig ratio back in for u, cosine of x equals 4 over 3. Well, cosine is never 4 over 3. In fact, it's never greater than 1, so there are no solutions here. But cosine of x equals negative 1/2 does give us some solutions. Cosine equals negative 1/2 at 120 degrees and 240 degrees. There are two solutions. Check those with our answer key. Seems to be correct. I think we'll stop right there.